All right, welcome back for our second day of IB Math Online. Today we're going to be looking at just some more applications that you can use to do integration with. Today we're going to look at a bacteria example. So reading through the example, it says that a culture of bacteria started with an initial population of 100. The rate at which the number of bacteria changes over a 1 month period can be modeled by the function r of t, with e to the 0.273 to the t power, where r is measured in bacteria per day. Find the population of bacteria after the culture was started 20 days later. Okay, so I'm going to scoot this up just a little bit so I've got some room to work. Put it over here on the side. Actually, I think I can work with it here. Okay, so here's what you've got to do. You're going to do your integral from 0 to 20 of e to the 0.273 t power dt. Okay, now what that's going to tell you is how much the population has changed. So let's first of all do the easy way, which is with our calculator. Okay, and then I'll take you through the longer, slower method. Okay, so with your calculator, you're going to go into math and you're going to go down to finite integration. When you're down there, you're going to type in 0 and you're going to type in 20. Move your arrow to the right key, then do second, e to the x, do 0.273. Now we don't have a t button, so we'll just use x instead. dx. All right, so you're going to integrate that, and it's going to tell you that you're going to have approximately 857 bacteria. Now that's the change from day 0 to day 20, but on day 0 we had 100, so we're going to have to add 100 on so that you actually end up with 957 bacteria approximately. Okay, so that's our super easy way to do it, but perhaps you end up on a section, well, I can't imagine you would have this one on a non-calculator section, but let's go through it by hand just so you can see what that looks like. All right, so if you're going to do this by hand, you have to realize that r of t, which is your function, you're going to integrate that e to the 0.273 t power dt. All right, now that's not just a plain x up there for your exponent right there. That's not just to the t power, so we will need to use u substitution. So over here on the side, I'm going to let u be equal to my exponent. And then I'm going to take the derivative of that. Okay, now we do not have those values, so let me just put that in there. 0.273, which means on the outside I'll do 1 over 0.273. Okay, they kind of compensate with each other. So now when I rewrite this, I'm going to have, if you want to turn that over to a fraction, it's pretty easy to do. That's the 1,000th position, so that would be 1,000 divided by 273. So then you'll have e to the u du, which integrates really nicely. It's just e to the u, and then I'm going to put my u back in. And because that wasn't a definite integral, I'll have to put a little plus c on it. All right, now, unfortunately, I got to find out what c is, but I know that at time 0, the value of my function is 100. So I'm going to use that to help me figure this out. So I will know that this function is equal to 100 anytime I let t be equal to 0. Okay, as it turns out, e to the 0 power is 1, just like it should be. And now I just need to use my calculator and solve for c. my C is going to come out to, and that's when I take 100 and I subtract this fraction and I do math enter, 26300 over 273. So that's what C is. So that means that my function, R of t, all integrated, would be 1000 over 273 e to the 0.273 t power plus 26300 over 273. All right, so in order to solve this problem, I need to know two different things. I need to know what the value of my function is at time 0 and what it is at times 20. So I have r of 0. That's given in the original problem. Now I just need to find r of 20. So that means you're going to take this function, the one that's right here, and substitute in a 20 and evaluate it using your calculator. And that's going to give you 957. So the change in r is going to be 957 minus 100, which gives you 857, which is what we got out of the calculator. But don't forget to add on the plus 100 that you started with, so that your total bacteria is 957 approximately after 20 days. That's our only example for today. Your homework can be found on page 326, and it's 9P as in Paul, numbers 1 through 4. So big takeaways on this is, yes, you can use your calculator. As you can see, the calculator was extremely fast. Just don't forget to add on your initial amount at the end, that 100 and the 100 here. So you want to find the change and then add on the initial amount. So that is your homework assignment. I'm going to be looking online for your questions about 9O and 9P. And as soon as you pass those along to me, I will be adding on some more information, some more videos having to do with that homework. Good luck and be safe out there.